I'm recording, so if someone's not here, they can watch it. So, here we go. So far, all we've learned is that inside of these two blue brackets here that are highlighted, that we can output stuff onto the screen, right? We can output words as long as they're in quotes, and we can also output math if we don't put them in quotes. Okay, 15 minus 5. So that's all we got so far. We're obviously going to want to go a little deeper than that. We want to be able to, first of all, store information somewhere. So let's say someone types, let's say we want to keep like someone's information in the computer. We have to make something called a variable. Okay, in any coding language, there's always variables. Okay, that will keep track of values for us. Now, some coding languages. Are you new today? Sit there, guy. Okay. Some coding languages, it just knows what type of thing you want to hold. Like some of the easier coding languages, you just give your variable a name, and then you set it equal to something, and it'll automatically detect if it's like words, numbers, whatever. C++ doesn't do that. So it needs to know the exact type of information you want to store in there. There's a few different types. The first one is called an int, an integer. Okay, just stores a whole number. I'm going to give mine a name. I'm going to call it num1. So that's the format there to make something to hold a value. Okay, now I'm going to see out that value and see what's inside of there. I didn't let it equal anything. I don't know what's inside of there. I'm just going to run it and see what happens. My program here. And when I run it, I'll see that my first line is there. It did the math for 15 minus 5. But it looks like right now there's the number 4,200,587 in this location. Now, yours might be different. It just found a spot in the memory of the computer, in the RAM of the computer. And whatever was in it, it doesn't necessarily mean that there's going to be the number 0 in it or the number 1 in it or whatever. Whatever was in it, that's what it found. Okay, so that's a dangerous way to code. It is always best to let it equal something like the number 70, for instance. That's how I can do that. So now, basically my code now sees the word num1 as the number 70. So it kind of replaces, anytime I write num1 anywhere, it replaces it with the number 70 when I code it. So if I go like num1 times 3, it should print 210 on the screen. Okay. It does do that. If I divide it by something, like a decimal, what's 70 divided by 6? Let's look. 70 divided by 6 is 11. Let's pick a number that doesn't go into 70 nicely. 70 divided by 6 is an 11, is it?
6 times
What?
11 is 66.
Yeah. Oh, it's because I'm on the programming computer. 70 divided by 6. Perfect. It's 11.6667. That should be a little bit of foreshadowing when it said 11. Watch what happens with my code as well. What's it going to say? It says 11, even though that's not right. Remember yesterday when I said in the lab, if you just have like whole numbers and you're doing math, it'll always spit an answer out as a whole number. Okay. So it would have saw this as 11.6667 or whatever, and it would have just chopped off the decimals. C++, computers have a very easy time converting numbers into ones and zeros, but they aren't as good at converting decimal numbers to ones and zeros. So that's why we have different types. We have an integer, int for decimals, and then we'll have tomorrow a different type to hold decimal numbers. Okay? And that number is called float. It stands for floating point number, which means the point can float around in there somewhere. Okay, so start on lab 4 today. Let me just see if I can see this value in the memory of the computer. Let's check it out for 1 second here. Hold on, let me open, close that. I wonder if it would. Let me just quit that for 1 second. Open my dev here. Devy. I had a different dev there that doesn't have the. I'll show you this little trick later. There's a lab on this, on a trick where you can stop the code and look at the variables and see what they all equal and see what all your numbers equal. Okay, so I'm gonna go. Yeah, I'll open this project. Okay, and here's num1. Okay, watch this. So I'm going to stop my code right at this line here, right at line 11. It's going to show me that num1 is now something different than it was. It's just some random number in there, 4200677. So it's just a random junk, whatever was in the computer. Now I'm going to skip down a line. I'm going to skip through and actually make the computer do this line. And hopefully you can see that num1 got updated to 70. Okay? And you'll see it down here too. Right now num2 is just filled with junk. It's this number in scientific notation, something to the power of -39. When I hit F7 to jump down to this line, you can see that it sets it to 50.5. Would we ever be able to see this in the as ones and zeros? Let's check. Memory dump. What does that mean? Okay. I want the memory at this. Hold on a sec. Let me see what the memory address is. Every number, every variable you make will have its own address in the memory of your computer. The address of this one is this really crazy number here. You don't need to know any of this, but I'm just going to pipe it in there. I am going to hit go. Okay. And I want it in. Well, that's weird. I'd like to see it in as ones and zeros maybe. Anyways, it says it's the number 46. Okay, does that make sense? No, because I actually had that as 70. But let me go to my programming calculator here. We're not going to learn any of this stuff. And I'm going to go to hexadecimal and write 46 and then hit equals. And look what it is in decimal. It's 70. So I actually can see in the memory of this computer. When I'm looking in memory, I'm actually looking in something called the RAM of the computer. And I actually see that this computer went into the my program went into the RAM of this computer and set this little value to 46 in this thing called hexadecimal, which turns out to be 70. So the computer, when we're coding and making variables, we're actually going into the RAM of the computer and using up one of its bytes out of however many gigabytes of memory you have on your computer. Most people have like between 8 and 32 gigabytes. So I used 1/32 billionth of the memory of my computer to store this number. And C++ knows where it is. It has its address. It can use it. It can. It sees it as the number 70. If you ever want to go and use it, you can. So that's how variables work for a very beginning lesson. Have a look at Lab 4. See if you can work your way through that. It asks you to do some little tricks, make your own variables. It asks you to name some variables and see what names work and what names don't. It asks you to add variables. It asks you for a few other things, okay? So work on that today. I'll post this video. If you aren't here, you can watch it today.